Hi everyone, this is your struggling CS student, and today let's solve another LeetCode problem of the day. Let's take a look at today's problem. 3228, maximum number of operations to move once to the end. It's a 1600 rated question, give or take, so it should be fine, I guess. Okay, so you're given a binary string S. Okay, you can perform the following operations on a string any number of times. Choose any index I from the string where I plus 1 is less than s dot length such that s of I is 1 and s of I plus 1 is 0. Okay. You want to move the character s of I to the right until it reaches the end of the string or another 1. For example, if we choose for this example string s, if we choose index uh, equals to 1, we'll move this to here, I suppose. It reaches the end of it. So, yep, okay, so it becomes like that. Return the maximum number of operations that you can perform. Interesting. We want to perform the maximal number of operations, not the minimum. Okay. Well, if you think about the maximum number of operations, then yeah, you just move from the left to right, right? Move from left to right until you can't anymore, then you move. Let's see. Yeah. So the output is 4. Okay, so in a greedy manner, you want to maximize you want to maximize, how should I say, you just want to move the ones from want to move the leftmost one to the next one. But I feel like it's easy to like construct a n square case. Is it? Let's see. So for example, if let's say you have like 1 0 1 0 1 0 1 0. So you move this here, so you get 0 1 1 0 1 0 1 0. Then you move this here, 0 1 0 1 1 0 1 0. Then you move this here, so it's 0 1 uh, 0 0 1 1 1 0 1 0. Then you move this 3 times. Then you move it 4 times. So what does that tell me? Yeah, I think it's possible to construct n square case. And I want to avoid that. So I think we can like keep track of the number of ones, kind of. So like we remove this here. It's like, okay, we see the 1. That means we have to move this one. If eventually, like we have to do the operation, right? So okay, we say we do one operation here. When we see another 2, you know, we have to do 2 operations. We have to do 2 operations because uh, one of the operations is performed on the first one. So then the string becomes 0 1 1 0 1 0 0 0 1 0. Now we can no longer move this. The next time we see this, because we want to maximize our operations, we would just move this and then move this. So each time we see a 1, we keep track of the number of ones that we've seen so far, excluding the one that we're currently thinking about. And no, we don't have to exclude it. We can just include it and just increment the number. So the number of moves required would be the number of ones you've seen thus far, including the current one. I think. I think. Yeah, I think it's most likely right. So let's do that. It's a greedy algorithm, I guess, or maybe like simulation. So yeah, let's do it. I'm not sure if it's 100% correct, but my intuition is telling me it's most likely correct. So we say the current number of ones, we set it to 0, and for C and S. Okay, so if C is, what we can do is current plus equals int of C is equals to 1. Right, then We need answer as well. Answer is equals to 0. And answer plus equals current. And we return answer. Never mind, that is horribly wrong. Why is that? We only want to add the answer when c is equals to 1. So if c is equals to 1, then we can do the operation, right? Okay, never mind, it's still wrong. Let's see. 1001 and 101. 1001 and then 101. So, oh, that's because we assume that we can move. We assume we can move. So we should only do this when the next string is 0. When the next string is 0. So if the current one is 1 and the next one is 0, then we do the move. We can't just do the move immediately, right? Yeah. Okay, that means we need the index as well. Okay, now we have the index, and then we say if c is equals to 1, and s of I plus, or rather, we need to do bounds checking, and I plus 1 is less than n, and s of I plus 1 is equals to 0, then we do the move. Okay, looks correct. Let's do some random inputs. Let's say 101010. Let's say 1, 0, all zeros, and all ones. And let's do a test. Okay, I'm gonna do a summit, but let's analyze the time and space complexity here. Time complexity is O(n) because we're just enumerating the input string once, and the space complexity is O(1) because we're only keeping track of a few variables. So, alright, cool. The solution got accepted, so let's take a look at the editorial real quick. Greedy plus counting. The problem asks us to calculate maximum number of operations to move ones to the end of the string. We can start by selecting one whose next character is 0, and then move this one to the right until it's blocked by another 1. And because each one maintains its relative position, its final position in the string is also determined. The more times one gets blocked during the movement, the greater its contribution to the number of operations. Right. So if we perform the operation on each one from right to left, then each one will need at most one operation to reach each final position. Yeah, meaning no ones will be blocked. Therefore, to maximize, we perform greedily from left to right. Yep. So for this problem, if we want to minimize the number of operations that we can perform, we'll actually choose an index from right to left instead of left to right. So, yep. So if we perform the operations, okay, yep. Therefore, to maximize left to right, yes, correct. Traverse the string for each segment of consecutive zeros. Add the counts of one that appear before the first 0. Interesting. Interesting. This algorithm. Let's see. Algorithm logic is as follows. Traverse the string S from left to right. Now for each segment of consecutive zeros, we add the count of ones that appear before the first 0 in this segment to the answer, since all those previous ones contribute to one operation each. If the current character is 1, we'll increment the counter, okay, by 1, indicating that there's one more one that can be potentially blocked later after computing the final answer. If s of I is equals to 0, and while s of I plus 1 is less than n, and the next one is 0, so we count the number of consecutive. Now we move the move the pointer uh, until we meet a 1, and then we'll count the number of ones that we've encountered so far that will be moved and blocked, I guess. For each segment of consecutive 0, add the counts of ones that appear before the first 0 in this segment since they'll contribute one operation each. Yeah, I guess it works. I feel like my code is cleaner. I don't know. Like, I feel like my code makes a little bit more sense, no? Anyway, it's like you have like nested while loops here. Maybe it's a little bit like harder to read. I don't know. Anyway, this is my code. Thanks for watching the video and have a great one ahead.